Hello, everyone, and welcome to this Telit webinar, How IIoT is Disrupting the Automotive Industry. I'm Amanda Flink, Head of Global Events here at Telit, and I will be your moderator for today's event. Before we start, we'd like to gauge an idea of your familiarity with the flexible factory floor and industrial IoT. So please, if you could take a second to fill out our poll question, which you should see on your screen now. Now let's get to know our speakers. To explain this topic today, I am pleased to be joined by two speakers. First, we have Ricardo Buranello, the Head of Platforms Business Unit here at Telit. Second, we have Ken Lively, Manager of Advanced Controls Engineering at American Axle and Manufacturing. Just before I hand it over to Ricardo to start the presentation, I have a few quick reminders for our audience. I would like to encourage you to interact by posting questions. We will have time to answer those at the end of the presentation. Simply submit a question by posting in the box to the right of the slides. Also, please be sure to check out the resources section in the upper right-hand corner of your screen for additional information. Finally, we will send out the presentation slides and a replay link to all attendees at the conclusion of this webinar. And with that, Ricardo, I will hand it to you.
Hey, Amanda. Good morning. Thank you so much for the introduction, and thank you everyone that joined this morning. It is a big pleasure for me to be here talking to all of you, and especially to have Ken Lively here on the call. Ken is one person that I know for quite some time already, a partner of Telit, and a person that brings an incredible amount of experience in automation and the deployment of IoT and Industry 4.0 on the shop floor. And certainly he has some really great stories to tell us. For the ones that are joining and maybe are not fully familiar with Telit, Telit's a global company. We're traded in London Stock Exchange. And basically the only thing that we do is IoT, with a very large focus on industrial IoT. Basically today, we connect one new machine every 1 second. Probably this is the fastest deployments in the whole world that are deployed with our technology. Specifically for the focus of this webinar, I would like to tell a little bit about our experience on industrial IoT that comes with the platform for IoT called DeviceWise. DeviceWise has its origin inside IBM. The product started to be developed in 1989, and in the year 2013, Telit acquired a spin-off of IBM Automation Group called ILS Technology, and then we bring to the Telit umbrella this incredible technology and tool for the market. DeviceWise is becoming a real standard, specifically in discrete manufacturing. In the automotive industry, for example, 7 out of the 10 largest car makers in the world, they use DeviceWise on the shop floor to collect data from all sorts of machines and interconnect them with different types of IT systems, deploying a complete Industry 4.0 scenario. Not only automotive is taking the advantage of this type of technology, we also have very large customers in food and beverage, pharmaceutical, heavy machinery, and others. And the reason why we are being so successful in this space, we grew 115% our business in the last 3 years, just as an example, is our ability of really delivering productivity to our customers by the deployment of this technology. I really like a lot this statement from Paul Krugman that he says, productivity isn't everything, but in the long run, it is almost everything. If you think in terms of the industry, a few decades ago, the industries, in order to survive on a highly competitive scenario, they had to move their manufacturing facilities, mainly from North America and Europe, to Asia, in order to find lower labor cost economy that they could keep the productivity of their lines. The next wave that is changing the reality is the adoption of technology, specifically digitization, to ensure the competitiveness of these industries. And this is the big wave that IoT is bringing to us. When we look at some research in the market, and I really like a lot this research from McKinsey, they say that from all the types of deployments in IoT, more than a third of the economic impact of IoT, of the outcome, comes from factory applications, where manufacturing companies can save from 5 to 40% on their cost of production by deploying this type of technology. But what is IoT at the end of the day? This is a picture of a non-IoT factory. And this is a picture of a complete IoT factory. And you might be telling me, listen, this is exactly the same picture. What makes this factory an IoT factory are not the controllers that they have, maybe in that smart crane over there, or in this machine over here. Maybe that CNC from Siemens over there, the AGVs moving parts around, the robot on the right-hand side, or even sensors to control the productivity of the people. It also doesn't transform this factory in an IoT factory having SAP ERP systems or Oracle databases or visualizations and SCADA systems, as well as AI platforms in the cloud. What makes this a complete IoT factory is the ability of interconnecting all the different devices, all the different machines with all the IT systems with an intelligent layer of connection. And basically, this is what we do here in Telit. This is what DeviceWise does. Telit won several awards in the market, and it's recognized as a leader in smart manufacturing platforms. I like a lot the way that ABI Research described DeviceWise, saying that compared to Kepler, DeviceWise has more advantage in lower latencies. Compared to Foghorn Systems, DeviceWise has more advanced IIoT integration capabilities. Compared to homegrown data extraction and edge intelligence solutions provided by industrial automation companies, DeviceWise has more flexibility and more advanced softwares. But what is DeviceWise at the end of the day? DeviceWise is a software that can be installed in any type of operating systems. You can install it in a Linux computer, in a Windows computer, even in Raspberry Pis or cellular gateways. When you install it, for you to collect data from any machine is simpler than installing a printer at your computer. You just click in devices, you select one of the many drivers that you have. So here, a few drivers that I downloaded to my computer, you can see Atlas Copco for torque tools, all the different FANUC CNCs and robots, all the different PLCs from Mitsubishi, open protocols such as Modbus, OPC UA, OPC-DA, all the on-ramp controllers, all the Siemens, all the Rockwells, among many other types of tools that you can connect. We have hundreds of drivers available for you to read and write. You just appoint what is the IP address, and then all the tag tree of the devices get auto-enumerated on DeviceWise for you to read and write without writing a single line of code. The way that you configure your application is just dragging and dropping blocks of logic in this visual configuration tool. You can decide when your triggers will run. You can set up a trigger to run based on a change on a certain tag, or you can schedule this to happen every second, every millisecond, or in a certain time or on a certain day. You can add expressions, algorithms inside DeviceWise. So the same way that you write a formula in Excel, you can take all the tags that you collected from the machine, you can write one expression, simply link the dots, and now you have your complete solution implemented there to collect the data, to transform the data, to add math. And then you can decide when and where you want to connect this data into your IT systems. As you can see, you can push this data to SAP, to databases, relational or non-relational databases, as well as to cloud solutions such as MindSphere, Azure, AWS, Google Cloud Platform, Microsoft, and others. So with this technology, you can collect the data from any machine, transform in data that is important for your operations, and integrate it with your IT systems. If you need to have visualization applications such as HMIs, dashboards, OEE, and other KPIs, for you to build these applications is as simple as building a PowerPoint presentation. You can use device-wise view. You can select what is the device that you already connected to device-wise. You can select your tag, and as you can see, all the data comes live from all the devices. So you can use this on a completely bidirectional way for you to have a complete visualization of your devices. You can also add alarms to change the states of the widgets that you put on the table. As in this video we are showing here, every time that you reach a certain threshold that you should call the attention of a certain operator or a certain manager on the shop floor, you can make this application happening. And what is incredible is you don't need to write one single line of code to get this done. Device-wise is also a completely bidirectional tool. So you can add buttons, toggles, or other things for you to make this completely integrated with your system. As in the video we are demonstrating, we are adding, you can add text boxes, and you can use device-wise to convert inputs inside electrical signals for your PLC, for example. Or you can add buttons for you to classify certain types of events that you have on the shop floor. With device-wise, you can collect all the messages that your controller is providing. But in certain situations, you might also require operators to classify a certain time of downtime so managers can understand what is consuming their downtime, what is consuming their productivity in order to increase their OEE on the shop floor. With this very brief introduction, I would like to pass the ball now to Ken Lively, and so he can tell us a little bit about his experience on the deployment of Industry 4.0 and IoT in the large factories of American Axle. Ken, thank you so much for joining, and I'm passing the ball to you.
Thank you, Ricardo. Pleasure to be here today. I'm glad to have an opportunity to share our experiences with DeviceWise and the journey that we've had recently with it. I'd like to start with just a brief introduction of American Axle. For those of you that are unfamiliar with the automotive industry, maybe you've not heard much about us. Some of you have. But I just wanted to touch base on who we are and where we've come from. We are a Tier 1 automotive, global Tier 1 automotive supplier headquartered in Detroit, Michigan. We were founded in 1994. We came out of GM as an asset purchase, not as a divestiture, but as an asset purchase. Initially, we started as 4 major facilities. We had a facility in Detroit, Michigan, which was kind of the central location. We had Three Rivers, Michigan, and then 2 facilities in New York, one in Buffalo and one in Tonawanda, which was a forging facility. Today, we are now spanning 17 countries, I believe, with 80 locations. So the growth has been huge over the past 20 years. We now have over 21,000 associates. At its inception, American Axle was our primary customer was General Motors, but today, while General Motors remains one of our good customers, we have over 700 additional customers that we support with our products. Internally, we're divided up into 2 major divisions. The first is our driveline division, where we make axles, driveline components, prop shafts, independent rear drive assemblies that go in passengers and crossovers. Our axles typically go into light trucks and SUVs. A lot of the vehicles that you see on the road today, those are our axles running in those. We also have a significant push. If you follow the automotive industry at all recently, you'll know that there's a big push into electrification, both hybrid and full electric vehicles. And that's been our push as well. So a lot of our products are moving in that direction. There's just a lot of activity going on. We have a number of major programs where we're supplying either hybrid componentry or full electric drive vehicles. Currently, the driveline division is spanning 31 facilities in 12 different countries across the globe. Our other division is our metal form division. Classically, our forging operations fall into that, but also that encompasses a lot of component machinery, component machining, and that's also spanning 34 facilities in 7 countries. So we also have a number of facilities that are either corporate offices, engineering facilities in different regions, and sales offices as well. Myself, I'm headquartered out of our Advanced Technology and Development Center located in Detroit, Michigan. We are right across the street from our world headquarters building on Dock Drive. The role I'm currently in is the Manager of Advanced Controls Engineering in that facility. We are responsible for our controls architecture across the globe as we go into new facilities or looking at our existing facilities as we deploy new lines. All the controls architecture that we put in place to do our assembly systems and other systems, that falls under my group to specify and to look at new technologies going forward. Since I joined American Axle, which has now been over 20 years, I joined in 2000. Prior to that, I was working on contract basis on several projects at American Axle. And ever since my involvement with American Axle, there's been a huge focus on production build data, machine performance data, getting all that data acquired into a system where it can be visualized, interpreted, and used to make intelligent decisions. If you don't have the data, it's always just an opinion. As you might imagine, when we started off, there was no complete architecture in place. There was a lot of hodgepodge solutions, a lot of ad hoc implementations, using a lot of off-the-shelf products, usually picked by a supplier to implement their systems. So we had, all the classic systems that you've seen in the past, whether it was Wonderware or Factory Link or Fixed Dynamics or iFix, all those systems. We had all of those systems, and those would kind of grow over the years. And what we found is that we needed a consistent data collection methodology. And we did what many other companies did, and that is we gravitated toward the OPC solutions. But what we did is we also co-developed kind of a standard middleware layer that we implemented everywhere across the board. Initially, we were looking at a PC-based architecture. We used Steeplechase extensively. And then eventually we migrated back toward a PLC, so it was classic PLC solution, but always with that OPC layer in the middle, because the OPC layer at that time made everything kind of universal and attainable as far as accessing data, and made it available to those upper layers which needed to integrate it or import it into your business systems or your historians. That solution that we co-developed, we deployed that globally. It was very reliable. It worked for years. But as our data requirements grew, as technology changed, as operating systems changed, and as basically the bandwidth of what we needed to collect evolved, we found it became inadequate. So we began looking for other solutions. And we kind of played around with different solutions for a number of years. But then kind of in 2015, it began to kind of gel for us. We had stumbled across DeviceWise, and we're looking at that as a possible solution. We ran into them at a trade show and wound up asking all the key questions that we needed to get answered, and they helped hook us up with a demo system, which we took back to our offices, and very quickly we found that we could turn that into a functional system. When we turned that into a functional system, we did our benchmarking on that, and basically our proof of concept offline, and decided very quickly to move that into a production system to prove its worth to us and decide where we were going to go with it. Some of the features that jumped out to us, and Ricardo touched on a couple of these things, and I'll talk about the ones that were important to us. Biggest one for us, performance. Our previous application that we used at the middleware layer because of the generation in which it was written and because it was an OPC-based kind of thing, it wound up being a single-threaded application, which normally worked pretty well, but as our demands grew, that became a problem. And DeviceWise, being a multi-threaded application, has a couple of unique benefits, primarily being performance. The other one is, Ricardo was showing you how to build a simple trigger. Those triggers can all be edited independently. They can be edited online while the production system is running. That became a huge benefit to us. Having that little logic engine in there where we could make decisions down at the edge was a powerful tool for us. We had previously been strictly data collection. We would identify tags and just simply pull them and suck them up, which was not uncommon. That's what most systems would do at the data collection layer. But being able to make that decision process, out at the edge and have handshakes involved where we could be sure that we had that data was important to us. The Workbench that Ricardo was showing earlier, that is well suited toward remote access. In fact, we always today use it in a remote scenario where the data collection node is down at the assembly line. We always run our configurations from a laptop or a workstation remote from the line, so we don't have to be on that physical PC. That's great from a security posture as well for us. There was a move toward what we found is that to enhance performance, DeviceWise has an extensive library of drivers that they've written that perform much better than putting that OPC layer in place. And I'll talk a little bit more about this later. This has a number of benefits that we have realized more over the years since we've been using DeviceWise that have really helped aid that performance side of things. Another advantage, and this is kind of inherent in the multi-threading, is that the PLC and database connections are all independent of each other. I can have a PLC go offline and the rest of the application keeps working, or a database connection go offline. I can put handling in there through that logic engine to make the system accommodate that and maybe send data to a different location or buffer it in a store and forward scenario. There's all kinds of different options that are available to us. And the last bullet here has to do with future proofing. We were using a legacy application that we were struggling with the path forward because we had paid a developer to do the work on it. We didn't always have the most timely response in getting to the next platform. As Microsoft rolled out the next version of Windows, we were waiting all the time for the next version of this application to make sure that it got installed. When we went to DeviceWise, they not only covered the versions of Windows, but they had solutions already cross-platform to go anywhere that we wanted to go. And so that was a future-proofing decision for us to say, we could go here, we could go there, we're covered. DeviceWise has that handled for us. So I'm sorry that this one's a bit of an eye chart, but I mentioned performance was key to us. We took and put in a controlled lab environment a somewhat typical scenario of performance. And if you look at the data points at the bottom, that's the DeviceWise response time in our database transactions. So we're reading from a PLC, sending data to a database, and those were the times that we're seeing. Now, understand, the system can run a lot faster than that. We were constraining the PLC in this case with a scan time of roughly 105 milliseconds. And that was so that we could get some differentiation between the different scenarios that we were looking at. So our baseline performance was basically one PLC scan. We had our response from the database. So we are reading tags, sending them to the database with a store procedure call, getting confirmation of a successful insert into the database, sending that back to the PLC and handshaking with the PLC to say we're done. All that's accomplished in one PLC scan. The dots that are above are what was happening with our legacy application. Because it was a single-threaded application, you're not only seeing a much higher average response time, and that also included the fact that it was an OPC-based solution where you have tags being created and destroyed all the time. But because of that single-threadedness, you not only see a higher response time, but you see all this variance going on. Mind you, this is a controlled environment. When you put this on the plant floor, the differences that we're seeing were 10 and 12 times what we're seeing here. So this was one of those things that just kind of sealed the cake for us. We knew it was responding better. We knew it was performing and doing things that we needed it to do, but we didn't know how well until we looked at this. So this has become a powerful tool for us in terms of justification for putting it in. So here is a cartoon version of a Purdue model, kind of showing a typical plant floor enterprise. And if you look in the middle of this, where I have something called SCADA PCs, that's where we position device-wise, typically. Now, this is only one way that we use device-wise, the primary way that we use it. We have some other ones I'm going to talk about in a second. But in our assembly systems, we have something that looks a lot like this, where we've positioned it above all the assembly equipment. It reaches out to those PLCs below, collects that data, sends it to a local database that is resident on that box. Upper level IT systems come down and read that data out of the local database and move it off for other systems for reporting and decision-making solutions that are managed by the IT department. But as far as the data collection side goes, that's kind of where we position it. So we launch one of those systems with every assembly line that we do. What we did is we took that proof of concept, those initial developments that we did, we put that into a set of templates. We published that in a book and we gave that out to our plants. Now, what Ricardo showed you earlier with how simple it is to put a trigger together was exactly right. It is that simple, but it can be simpler. One of the things that we found is that was a very powerful feature for us is the fact that all of the configuration you can export into an XML format, modify, import it back in. And that's one of the primary ways that we deploy these systems. We have a set of templates that we use to deploy to every station online, where we take a text XML file, modify it to what we need, import it, and then just go through station by station with those modifications. And in the span of half an hour, I can have the entire line functional with this system. We go in after we have that first level of functionality, which covers all the handshaking, all the basic transactions, and then we add all the specific stuff for those stations. If we want to collect additional data or we want to retrieve additional limits, we add those in. There's placeholders there for that. We do all of our interaction with the database with store procedure calls, and we have in the configuration inside DeviceWise, we build a transport map, is what the term that they use for it, where we have all of those parameters identified and templated into our transaction blocks. And now, while we have gone through some training with our personnel on the floor, one of the things that we found is that we hand this book to our engineers. They take off and they run with it. In the first system that we deployed, when we were doing our proof of concept in a plant, we had developed this book offline. We were ready to go with it. I sent it out to the plant and then scheduled to visit the plant the next day, next week, to kind of get them started. I got out there a week later, sat down with them and said, okay, so we're going to do this, we're going to do this, They looked at me funny. I couldn't figure out why. They looked at me and said, well, we're done. It works. Can we turn it on? So it was that fast and that easy for them to do that using this method of the imports and exports. We have a separate system where we've actually taken that import-export functionality kind of to the next step. We've built it into an Excel spreadsheet where they fill out a bunch of configuration cells, hit a button, and generate a set of files that they can import, and the system is done. On that system, no one actually does any hands-on device-wise work inside the triggers. It's all automated for us. So the speed of deployment there is just tremendous for us. So in a typical system, we'll have the project tree that looks something like this. And when I say, the reason I'm showing you this is we try to keep this as simple as possible, because one of the things I like to do is, in some sense, I like to discourage excessive creativity. While it's a very capable thing, I try to keep my hands on what the standards are and keep people adhering to those standards. That makes things more supportable going forward, which is generally a good strategy. But what we find is that DeviceWise is so easy to understand. and so easy to work with that where I take this as what we would expect to see. I logged into a system recently in one of our plants and found all kinds of stuff going on. They've taken the system where I would expect to see two elements in the project tree, one for the triggers and one for the resetting of the triggers, and they've added all this other functionality for all these other systems, and they did it in the span of a few weeks. And so some of these things are being adopted now into standard methodology, and some of these things we've looked at and said, no, these are one-off kind of implementations. But they did this, and it did not really affect performance of the base system underneath. So again, the performance criteria that we used has been significant. So another area where we use DeviceWise is a device called an Atom Box. This is the predecessor to a current product called the Smart IO that Telit has. This was kind of the first generation of that. It was developed as a concept, I think, kind of as an ad hoc solution. And this was really about the same time that we were adopting it for our assembly lines, that we were adopting DeviceWise. This is basically an I/O box that we can tie to a CNC machine. It can bring in a number of data points, specific discrete points. It has both digital and analog capability, but we use only the digital inputs in our implementation. And we're looking for things like whether the machine is on or off, whether it's an auto, whether it's cycling, whether there's a part present, just basic signals to do machine monitoring. And we looked at a number of different solutions on how to get there, and this custom solution at the time was kind of the best choice for us. So we co-developed it with them as far as what the functionality needed to be, and it was a very simple implementation. That was kind of key to the whole thing. The box itself, even though you could run DeviceWise on small form factors like a Raspberry Pi, this does not run DeviceWise by itself. This simply reads the I/O, timestamps it, formats a message, and sends it out via Modbus TCP. It has an Ethernet connection on it to which we hook a wireless bridge. So we run out to the plant, slap this on the side of the machine, hook up a wireless bridge so that it can reach back to through the network to a server, and then we just simply tie in those I/O points that I was talking about. So the deployment of this, I mean, it's fairly simple to put in there. We just it'll mount to a DIN rail, or it can screw it to a backplate. You provide 24 volts, and you provide those signals, and you get those signals sent back to that server. On that server, we have a listener out there that listens for those Modbus TCP messages, and it turns that into FIS state changes. So it's kind of a very quick way to get a full-blown FIS in terms of monitoring your machine utilization. And I'll key on machine utilization because that's the payback for something like this in the short term. The big money payback on this is keeping a handle on utilization in the plant. And we found that this was exposing to us places where we had machines that were down that we didn't know, or machines that were running cycles that we didn't expect and not getting the throughput that we expected. So by putting this application together, which was relatively quick to deploy, we began to get a handle on all the CNC machines in a plant, and now you start to get a picture of how much uptime and downtime you're seeing on all those machines, as well as part counts. So one of the things, for example, that we found is here's a machine that was running with a 67 or 76 second work cycle. Basically, this is time on part. Every so often we would record a work time that was essentially double that. And what we found was that this was a case where we had an operator that was servicing several machines. So he'd load the machine, hit the buttons, doors would close, he'd walk away to the next machine, and he would be tending a series of machines. So he had a cycle that he circulated in. And what we found was that even though he hit the buttons and the door closed, he didn't keep his hands on the button long enough to see that the servos were enabled and that motion had started. It was a case where we just didn't have enough feedback for the operator to know that that had happened, and he's trying to get around the cycle as fast as he can. So he's doing his job and doing it well, but just not quite always getting that motion started. What this led us to was A, identifying the problem, and then B, putting corrective action in place where we could put an alarm on that so that when he started to walk away, we got his attention to come back and hit those buttons and finish. Then this issue went away, and we started to get the throughput that we needed out of that machine. So again, utilization is the big thing. Keeping those machines up and running is critical to us. So the other solution I want to talk to you about a little bit is, I mentioned that we're future-proofed when we chose DeviceWise, and in going forward, it wasn't just the platform in terms of the operating system. We were future-proofing because the capabilities of DeviceWise are very easily expanded by adding different packages. You add packages for different types of controllers that you want to talk to or different devices that you want to talk to. But then there's also packages that give you capabilities above and beyond that. But I want to talk first a little bit about some of the things that come in the standard packages and how we're starting to use those in Industry 4.0 initiatives, separate from just simple raw data collection. One of the things that we have done recently is we started to move on our CNC machines where we have these atom boxes. The next level of what we want to do with those machines is getting a interface, Ethernet interface into those machines and start to collect more information out of them to do other things. We want to know, what program is running. We want to know tool life information, things like that. So we're looking at channels by which we can get direct connection to a lot of these machines. DeviceWise is well suited to that. They have drivers for a lot of these machines, whether it's a Siemens 840D or whether it's a FANUC with Focus library drivers. They have those capabilities, and if not, they can develop them. They have those skill sets. So we're starting now to push into connecting these machines and now getting not just machine performance information out of them, but we're looking at the extended functionalities that would gain us more value. Optimizing tool life is one of those. That's a good example of that. Another thing that we have started to do recently, and this was an initiative that was initiated by the plant playing around with our functionality that we had already delivered. They found that a simple Cognex camera on the plant floor had the ability to send an image to an FTP server. They were reading on the DeviceWise screens that there's an FTP server built in. And so they started to ask some questions, and they contacted us, and they said, could we have a image sent to DeviceWise and then sent up into our system so that we can add it to reports? What they're looking for is error-proofing images. When something fails, they want to know why, they want a picture of it, and they want to archive that. And so we in the span of a couple days, we put together a solution by which we send that, interacted with the PLC to confirm, A, what the serial number was. We integrated a third-party package which allows us to modify the image and embed the serial number in a banner at the bottom of the image so that whenever you look at that image independently, it has the serial number included. We invoke that third-party tool and then forward that image through DeviceWise to a separate repository where it's picked up and then moved into long-term archives. Very quick to deploy, but this has in one of our plants, this has become standard practice. They do this every time they have a camera, and now they're capturing every time they cycle a part, whether it's good or bad. They keep those images for a period of time. It's proved to be very valuable to the plant. Again, not something we planned on, just something that was there, and we utilized it. Another thing that we have done recently is we've collected data from a PLC. While that sounds pretty boring, what I want to highlight here is due to the way they've written the drivers and the way that we're not doing standard OPC interfaces, we're utilizing the way Telit has written these drivers. What we found is that it is very easy and very efficient to not just pick up what we call scalar data, individual tags or individual data points. We can pick up structures. So what we can do is we can build a JSON structure that matches a UDT and a PLC. And yes, we're using Rockwell PLC, so we have UDTs that structure our data for us. I can build a copy of that data into DeviceWise and read it in one read. And what we're utilizing this for is I can take a data structure or a set of coordinate pairs that we use to draw, say, a press curve, and I can read that entire curve in a matter of milliseconds. When we initially had a requirement that said, can we gather some data points for a curve, I was reluctant to pursue that because I said that's going to add cycle time to your machine, and that's bad. So they dropped the requirement down. They said, well, if we can get 10 points or 12 points or 15 points, that would help us define the curve, at least the point of interest that we're after, and that'll be enough. And as we got into it, what we realized is that it doesn't matter if we collect 10 points of that curve or if we collect 500 points of that curve, it takes about the same amount of time. So I have machines that I can read 3 different press strokes, each with 500 data points, and I can do that still under 100 milliseconds. It works fast, and it works seamlessly underneath the regular motions of the machine. So I'm getting all this data now in the same cycle time. It does not impact cycle time for us. That's becoming a huge benefit for us. One of our recent activities is we're now adding a package called the Cognitive package to move data into AWS. And that is, we're taking the same data that we would be collecting. Right now, we're collecting the same data that we had before, and we're simply moving it into AWS. And what we're doing is we're writing it to a Kinesis data stream, or we can write it to an S3 bucket. It doesn't matter, or you can do both. In fact, we are doing both currently. This is allowing for different solutions, analytic solutions, that now instead of having to go through mining the repositories that the data lives in, whether it's the local database on the SCADA PCs or the IT server that stores that data, they would have to write a Python script to go and read all that data, and on an interval they would upload it into the analytics engine. Well, right now, by the time that part leaves the station, it's up in the analytics engine already, which gives us much more time to response as far as predictive maintenance goes. One last thing I wanted to mention is we have some cases where we've implemented a product called Beat. And I'm not here to sell you Beat. That's not my purpose. But when we first looked at Beat as a product, what it is it is something that helps us look at the motions, the actions that happen in individual machines, benchmark them so we know when things are supposed to happen, and establish kind of a baseline of machine operation. Then it monitors that over time and reports on deviation, saying, you know, this slide is taking longer, this motion is taking longer, and raises alarms on what that is. That is expanded, and there's additional functionality as far as, you know, optimizing your assembly. And I'm not trying to oversimplify what Beat does, but basically that's the functionality there. When we first looked at Beat, they were using traditional, actually OPC-based data collection in a polling scenario. And they required a huge driver to be loaded into the PLC, so there's a big code footprint that went with that. And we looked at how that would scale up over time, and we began to have some serious concerns. So we met with Beat and said, hey, we've had some good experience with this product called DeviceWise, and introduced them to DeviceWise and said, there's other solutions that we can do. And what we wound up employing was unsolicited messaging from the PLC layer up into the Beat servers so that we have much more efficient transfer of data. It happens only when needed. We don't have to have this polling scenario, and it reduced the footprint of that code. That's the standard deployment that Beat uses today for our systems, is that unsolicited messaging for transferring the data. So again, you have traditional, data collection methodologies, which those all work. They work fine. You can actually, even with DeviceWise, you can put it into an OPC layer if you wanted. We have done solutions with that. but you can do these solutions where you can gather data structures, you can do unsolicited messaging, and reading, large blocks of data at a very fast rate. So there's a lot of functionality that this is enabling for us with the capability of these drivers. But I would say that the most interesting and forward-looking one for us at the moment is this path of taking data into AWS and using it for these higher level functions that we have not been able to implement effectively today. So this is kind of where my focus is right now and my interest with the product, and it's working very well for us. We just have recently deployed that and purchased the licensing for that. So it's kind of a new venture for us, but it's one that's very exciting for us. So that kind of concludes the things I came to talk to you about today, and I'll turn it back to Amanda and kind of open things up for questions.
Yeah, thanks so much, Ken and Ricardo. That was great information there. Audience, before we get to the questions, I am going to drop one last poll for you here. If you'd like to have one of our experts contact you, please respond here on the poll that you see on your screen, and someone will reach out to you. We do have time for some questions, and there is still time to ask a question, so go ahead and use that box to the right of the slide presentation, and we'll do our best to cover it in the time we have left. We have gotten a few so far, so we'll just dive right in here. First question I've got is, can DeviceWise be used to collect data from remote machines?
Yeah, I can take this one, Amanda. Thank you so much. Definitely yes. DeviceWise is a very flexible platform. It can be deployed exactly on the scenario that was brilliantly described by Ken. That is typically on the shop floor, and everything is reached by the same network. On the other hand, you also can have all the same functionalities running this on a cellular gateway. So imagine if you are, for example, a machine builder, and you are building machines and shipping to your customers all around the world. You can ship your machines with a gateway from Telit with DeviceWise installed on it, and you will have the ability of collecting all the data, doing all the visualization on premises, but as well as providing a full cloud capability for you to remotely monitor this equipment, set alarms, collect all the variables that you need to monitor, and eventually, if you need to add to do something, any actuation on this machine, you can use the tunneling capabilities, reaching out the gateway or even a layer 2 tunnels for you to reach out the controller of this machine, giving you the ability of selling machines as a service out of because of this functionality of IoT.
Great, thanks, Ricardo. I think this one is for you also. If I wanted to test this, how would I go about doing that? And can I buy one license today?
Absolutely. It's extremely simple. Please feel free to reach out to us. The licenses, they are completely delivered on a full electronic way. As we have hundreds of drivers in our driver list, basically most, if not all, the machines are connectable through DeviceWise. So you can collect this data. You can define where you will install it. It could be on a centralized servers. It could be on edge devices there. It is extremely simple. On top of that, all the documentation is ready, and we have a vast library of videos that, so this will most probably be plug and play, but we also can provide training on a completely remote way.
Great, thank you. Ken, this might be one for you. The Atom Box appears to be an effective solution, but what were some of the challenges that you encountered in deploying them?
Yeah, at its core, it is a very simple solution, at least at what it appears to be, because you're just tying in I/O points. What we found is the difficulty on that when you deploy them is sometimes those I/O points aren't necessarily accessible natively on the machine. Sometimes you'll have access into the machine where you can drive I/O points that give you the signals you need. But what we found is there's sometimes when you don't have access to the programming on the CNC, for example, you may have a proprietary machine that you can't get into and add I/O. You may be able to contract with your machine supplier and have them do it, but sometimes that's not even possible, in which case then what you wind up with is you have to put in isolation relays and separate those signals out electrically to feed into the Atom box. And that'll be true of any platform. That's not an Atom box or a Smart I/O thing. Just when you're monitoring a CNC, if you don't have access into the I/O of that CNC, sometimes you have to get creative with that. And tapping into the stack light is not always the best solution, particularly for alarms. What we found is that if we tapped into it and thinking that the red light was the alarm and we were all set, what happens when the alarm light starts blinking? Are we going faulted off, faulted off? That's not always the case. So sometimes there's some conditioning that needs to happen as well. So there's a number of unique challenges that happen on individual machines, just to be aware of.
Great, thanks. We do have a few more here. Next question, what is the difference between DeviceWise and other OPC solutions?
So this is a very good question. I think that Ken described some of the differences. So yeah, depending on the OPC solution, there are a couple of very common names out there. Probably Kepler is the most well-known solution. The first difference is when you are running OPC solutions like that, what you will find is a very complex environment for you to set up your application, and also high latencies on the system, as it was described by Ken in one of his slides that he shows the chart with the points plotted on the chart. DeviceWise was built to be a real-time data collection platform. Our drivers, they are written bare to the metal to guarantee real-time data collection for all these machines. But this is just one of the many differences that we have. Of course, it's important in a discrete manufacturing process as the ones that American Axle has. Every latency in the system will augment the cycle time, what will decrease your productivity. Also, if you cannot collect data fast enough, you always have the risk that the data that you're collecting is not reliable, because when you are pulling for the data, maybe the data from the last cycle of the PLC was already trashed and moved to the next one. So you might be collecting data that is not reliable. And these are the differences on the data collection. But on top of that, think DeviceWise not only as a data collection platform, but as a complete IoT platform. So you can transform the data that you collected. You can do parsing. You can add math. You can read how many tags here, transform this in a KPI or in an OEE ratio, and push this ratio both to on a screen with the full SCADA capabilities that we have on the DeviceWise view, or interconnect this with all your different IT systems. So pushing these informations, for example, for a ticketing system as SAP PM is as easy as just read the data, define what are the BEPs that you're using, and push this, open the ticket in SAP like that. And you can even think in terms of more sophisticated types of use cases. DeviceWise can connect to your MES system. We can understand, for example, what is the next part number to be produced. Based on this information, DeviceWise can collect the recipe for a certain controller and write back on the CNC or the PLC the recipe to be produced on the next part number. You can collect this data in real time and transform this in information, create a control room with dashboards for your managers to have a complete visualization. On our cognitive solution, we also can interconnect all your devices directly to Microsoft Azure, Amazon AWS, Google Cloud Platform, IBM Watson, and more. So it provides you the ability of deploying full projects without writing code.
Thanks, Ricardo. Next question I have here is, what kind of training has been required for end user and support personnel?
I could talk about that from my experience. We've had, I think, 3 different occasions where different plants have asked us to contract Telit to do formal training, and we've worked with Telit on the content of that class and tailored it to what we needed. But we've only done that in 3 locations. Every other location that we have put DeviceWise in, they look at the product, they play with it, they look at our manual, try it out, and then they decide whether they need it or not. And in general, they decide they don't need the training. And honestly, it's the sites that decide they don't need the training where we see the most innovation going on. So it's a very easy platform to understand, get your head around, and to take advantage of without a whole lot of formal training. Now, the formal training I would still recommend because it exposes you to all the other features that may not be in what you see on a system that you look at on the floor that you find.
Great, thanks, Ken. The last question I have here, we have many plants. Do you support a site and or global license model?
Absolutely. So DeviceWise is a very scalable platform. It comes in different sizes depending on the size of your deployment. You can start by collecting data basically to, 20 machines and keep growing this. And certainly we can provide a full support for all-you-can-eat type of agreements that will be able to collect every single license in a certain plant or even across multiple plants.
Looks like we just got one last question in here. In DeviceWise, is it possible to use PLC tags without having the device physically connected to the Workbench, or do you always need to be online?
No, you don't need to be online. So basically, certainly the controller needs to be at your network, and the connectivity from DeviceWise to the PLC or to any tool that you have at your network goes through Ethernet. Basically, the only thing you do is you appoint to this device, and then you get all the tag tree auto-enumerated. You can download the structure of tags that you have, so you can work on your projects and then deploy it offline. DeviceWise also has a functionality that is called store and forward. So basically, you don't lose data. We make sure that under the eventuality that your network is not up, we still store all the information in the internal memory. DeviceWise comes with a full LightSQL database within it, and then we can guarantee that the data will be processed and delivered even in the circumstances that you have instabilities at your network.
Great, thanks. Well, I believe that's all the time we have for today. We're coming up on the hour, so please be sure to check your inboxes in the coming days for the slides and replay link. I want to thank Ricardo and Ken for the great information day, and thank you for all who